Lesson 5 is focusing on absolute value equations and how to solve them. So before we talk about solving equations, let's just remind ourselves of what does it mean to take the absolute value of something. So for example, if I want to take the absolute value of 3, it's just going to become positive 3 because its absolute value is really representing the distance away from 0. So even if I say negative 3 and I take the absolute value, that's still going to become positive because it's still 3 units from 0. So positive or negative numbers, when you take the absolute value, it's always going to be positive. So what that means is when we solve an equation, if you have something where a is some expression in absolute value bars and it's equal to something that's not an absolute value, that's equivalent to having both of these equations. You have to have the case where it could have been just the positive in the absolute value, so a might have been positive to start, or you might have had a negative to start. So this works as long as b is greater than 0. Another rule is if you have an absolute value set equal to 0, you can really just drop the bars and say, well, that just equals 0 because there's no plus or minus when you're equal to 0. So let's look at some examples. When you're first looking at this, the first thing you always want to do is you want to isolate the absolute value. And the reason why you need to do that is so that you can apply that first rule. Once you have the absolute value by itself, then we have two situations. We have the positive case, and then we have the negative case. So in this case, the first thing I need to do is I need to subtract 5 from both sides. And once I subtract 5 from both sides, I'm going to get 2/3 x minus 3, still in the absolute value bars, equals 7. So then what you're going to do is you're going to set this into two situations. You're going to have a positive case, which is going to just mean keep everything the same. So it's going to be 2/3 x minus 3 equals 7. And then you're going to have the negative case. The negative case means you're going to write the opposite. You're going to negate that 7 because what happens if the inside was originally negative? So you can take care of that by just negating the 7. So you're going to drop the absolute value bars and negate the 7. And now we just have two equations. So now you just got to go through and you got to solve these equations as normal. So add 3 to both sides. So we get 2/3 x equals 10. We want to get rid of the fractions, so multiply everything by 3. So those cancel. We get 2x equals 30. Divide everything by 2. And we get x equals 15 for this one. Then we do the same thing on the right here. So add 3 to both sides. So we get 2/3 x equals -4. Again, get rid of the fraction by multiplying by the denominator. So the 3's are gone. We get 2x equals -12. Divide everything by 2. And we get x equals -6. Now, whenever you have any absolute values, you need to check your solutions. It is possible that you're going to get something that's not going to work out. So, in this case, both of my solutions check, but make sure that you check solutions. You have to check solutions for these. There are going to be times where you're not going to get something to work. But in this case, both of them do. If you go through and check it, you'll see that they do work. Let's look at an example where we don't have it working out. So basically, when I look at this example right off the bat, I know immediately that this has no solutions. And the reason why this equation has no solutions is because it's saying that the absolute value is equal to a negative number. And absolute values can never equal a negative number. So they can never be negative. So that means I have no solution for this. So absolute values can never be negative. So therefore I have no solution. So since my entire absolute value is equal to a -4, that tells me that this could never happen, so there's no way that I could plug in an A and get this to work out. So there's no solution to this. Now what happens if you didn't see that right away? Like what happens if you looked at this and you're like, okay, I'm just going to go through and solve it. Well, this is why you want to check your solutions, because if you go through and you solve this, you do 3a minus 6 equals negative 4, and then you do 3a minus 6 equals positive 4, you solve, you get a values, you would plug those a values back into this, and it would show you that it's never going to be true, which means your solutions didn't check, which means there's no solution. So if you don't recognize this right away with that negative, then you just have to go through the process and you'll see that your answers won't check. So definitely always check your solutions when it's a negative or when it's an absolute value. So one last example here. Um, just another scenario. What happens if it's an absolute value equal to an absolute value? What do you do then? Well, it's really not that big of a deal because it's going to be the exact same thing as what we did before, where you're going to set one equal. You're going to basically drop both absolute value bars, and then you're going to have a second situation where you have one equal to the opposite. So I'm going to have my two situations. So I'm going to have x minus 5 equal to x minus 7. And then I'm going to have the other situation where I have x minus 5 equal to negative x minus 7. Notice I put the negative and then I put parentheses. The reason why is because you're negating each piece. It doesn't really matter when you do this if you wanted to negate the x minus 5 or if you wanted to negate the x minus 7. It doesn't matter which one you choose, because if you think about it, if I divide everything by negative 1 right now, I would have negative out in front of this x minus 5. So in the end, it's all equivalent. So you just pick one side to negate. Just make sure you negate every part. And then from there, you're just going to go through and solve this. So this one I'm going to do plus 5. So I get x equals x minus 2, subtract over the x. So we see that my x's cancel and I'm getting 0 equals negative 2. Remember when we had this situation before? Whenever you get something that's not true, that means there's no solution. So there's no solution for this case. It doesn't mean that there's not going to be a solution though for the other one. So over here, first thing I need to do is I need to distribute that negative 1. It's going to be a negative x plus 7. Bring over the x minus 5 equals 7. Bring over the 5. So 2x equals 12. Divide everything by 2. We get x equals 6. And then you have to check this solution. Make sure it actually works. And when you check it, it does work. So that means my solution to this is going to be x minus 6. Now keep in mind when you guys are solving these equations, it doesn't matter, like notice over here on the left, I added 5 first. Where on the right, I decided I wanted to add my x's first. It doesn't make a difference what I move over first until, you're just making sure you get x's on one side and your numbers on the other. So in the end, we get one solution and we check. Always check for these and always make sure you have your two cases. You can't just completely drop the absolute value bars and ignore them. You always have to have your two cases. I always see errors with these where I've seen individuals just drop the absolute value and just pretend like they never existed. Remember, you have to have two situations, your plus and then your negated situation. And always check your solutions. And that's really it for solving absolute value equations.